Hello, and welcome to day 22 of our Cloud Run series. Today, we want to take a look at being able to run AI and ML workloads on Cloud Run. Now, the idea is not to do training on Cloud Run, but is to run inference. And so if you have some model, if you want to be able to host some open source model like Gemma, something from Hugging Face or Llama, you are able to do that on Cloud Run. So the main idea here is when you want to host a model that you can query, so that can be your own model or one of these open models that you just want to query, not for training. If you want to do training, Vertex AI is one of the solutions that you can consider on Google Cloud. But if you want to focus on just getting answers, on just asking your model questions, on just inference, then you can do that on Cloud Run. Now, Cloud Run does provide you with a host of options when it comes to hosting your AI applications, right? Because, Cloud Run allows you to also save costs, right? The request comes in, Cloud Run handles it, and then after it's done, it can just, dial down and allow you to save on cost. Now, some of the options that you have is you can host AI agents, especially with Google ADK. If you want to host your agent to agent with the agent to agent development kit, you can do that. You can host your MCP servers. You can also have GPUs, right? Which is what we are going to be looking at. So with Cloud Run, you are able to attach GPUs with your services, and then that allows you to take advantage of those GPU instances. So when you want to host AI models, Cloud Run provides you a variety of options. So in terms of the server that you want to go with or the software stack that you want to go with, you might want to think of maybe Olama or VLLM for your production LLM applications. If you have something with if you have something with Hugging Face using Transformer JS, then you can also host that on Cloud Run. So if you come here, you should be able to see a very simple code lab that you can just reference. And it's as simple as setting up enabling your API, setting up your environment, creating or setting up if you already have your Transformer JS application set up, then you can go ahead to use it. But then there's an example of you setting up your Transformer JS application, and then you just go ahead to here you build the image and you put it into your artifact registry, and then you specify that image as a variable, and you go ahead to deploy your service. Now, the Cloud Run integrates tightly well when it comes to the GPU with the NVIDIA L4 GPUs, right? And those allow you to optimize your inference because they are more optimized for inference, right? So the NVIDIA L4 GPUs are what you will probably have available, and they are much more cheaper than if you are looking at maybe the T4 GPUs. So this is a very good way to run your models that you want to use just for inference. Because with Cloud Run, per you only pay per second. So if no one is running a query, you are probably not paying, right? And even if you are going to be paying something, you are going to probably, if you are using, let's say, where is that? I think I missed it. Yeah. If you are using the request-based model, if you are using the request-based model, right, then you are doing something like paying for the idle time. But when you are using the NVIDIA GPU, you need to be using the instance-based billing, right? And you will only be paying for the GPU that you only be paying per second for the resources that are being used, right? So if no one queries your model or no one infers from your model, then you're probably not paying nothing compared to if you have a GPU on your VM where you are going to be paying, right, for the GPU, whether anyone whether someone is using the application or not. Now, yeah, as I mentioned, you have several options. So you can use Olama, you can use VLLM, you can try on Hugging Face. You have a couple of options if you want to host the model. The idea is that you need to provision enough resources to be able to host the model and to be able to load the model, right? Now, for instance, if you take the Gemma 3, which is around 4 billion parameters, right? It can take up to about 8 gigs of storage, right? So you need enough storage to be able to host the model in the first place, right? And at the same time, there are a few considerations that you should note, right? So one of the things is you can just load that model in your container image, right? So this is slow, but if the image contains much more smaller model, then it works well because once your container is started, right, it can then always be used at least till you have used up the concurrency and then a new instance needs to be spin up. Another way you can basically load the model is through cloud storage. So if you have a volume mount, then you can also load the model through that volume mount, right? So if you look at when you're deploying a container, you go to your containers tab, you can go to your volumes, and then you can go ahead to mount your storage right here. I think, okay, Google Cloud has changed the UI a little there. So you can specify your mount path, you specify the bucket where the model is loaded, and you are able to also load the model basically from memory, right? Of course, you will need your container or your code to be able to kind of load that model from memory and then use it from there. And you also have the option of loading it from the internet, right? You can put it into the containers, but if you are putting it in the containers and you have a CI/CD pipeline, you need to just make sure that you have enough memory and CPU to be able to load or build that model, right? And basically put it on Cloud Run. So you need to consider that if you are storing it in container images and you have some kind of a build pipeline. In this case, for instance, you are looking at using something like Cloud Build, and so you can use a much more powerful machine to then host um, your build process. And that can help you to be able to basically deploy your models to your Cloud Run application. Of course, yeah. So you can store it in cloud storage if you want. You can put that model into cloud storage and you can also load it from the internet, right? So if you're optimizing it from the internet, then you can have something like CloudNAT. I think we covered this in one of the days. I will just find that and put it maybe in the notes. But you can set up CloudNAT to be able to reach the public internet and then load your model, right? Now, I want us to try to load a model. I don't think it will work, but let us just try to load the Llama model and then see how it goes from there. I'm exactly not sure that this is going to work, but let's just see. So we are just going to use Google Cloud Shell and then we are going to try to load the model, the Llama model. I was trying to find this. Okay, let's close this tab. Let's close this tab. Yeah, okay. So let us put our Docker file there. I will just use nano. Uh, I'll just use nano, and then yeah. So you have the model. Yeah, store the model weights. So that is why you need enough memory because you also need to store the model weights. And then let's see. Yep. Yep, Olama serve and Olama pull the model. Yep. So we are trying, what we are using is the Gemma 3 4B. So you could provide an environment variable which could then replace the model, right? But we are having a default value of Gemma 3 4B. So you can use Olama to serve your Gemma model. And yeah, so we have this, and we are going to try to deploy, right? This is where I think it will fail because I have not requested for any GPU, but let's see. Because sometimes based on your usage, Google Cloud can increase your quota based on your usage. But let's see. Let me see if there's anything I want to change. So maximum instances is one. We have one GPU, no CPU throttling, no allow unauthenticated. That is fine because we will use Google Cloud Proxy to proxy the request to a local host and test it. So it's fine if there is no unauthenticated request allowed. We are using 32 gigs of memory. That is fine. Um, CPU is 8, concurrency is 4, which is the same as the Olama parallel, Olama number of parallel environment variable. And yeah, NVIDIA 14, maximum instance 1. Sorry, it's not 14 now, 4. Uh, yeah, let us see. Let us see. Because I don't have any GPU quota, so I'm not exactly sure. Let's see. Yeah, I do not have any GPU quota. So in order for it to work, you would need to request for a GPU quota. That is what I was trying to find out here. And if I look at it from this side, where is Europe Central? Where is I'm not able to really filter by the region when it comes to the quota. I'm not sure why. Let's try to sort a bit by the location and see whether why is it a lot? Uh, sort back down. Yeah. Yeah. So US will come in and then we can find US Central one. Yeah. I have no quota. So this is a situation where if I wanted, then I can go ahead to request, for some new quota. Right. Or because at the moment I don't really have, because it's based on your usage, then Google Cloud will determine that, oh, okay, we need to, allow this person to kind of have this particular type of machine or something like that. If not, then you would have to contact the sales team to request for a new quota. So let's see here. Yeah, so we are not able to host our model because we don't have any GPU quota. But these are some of the things you would just need to know or understand if you wanted to do anything AI on Cloud Run. There are just multiple options. If you have your own AI agent and you wanted to host it, you can host it on Cloud Run. And the beauty of it is that you don't need to pay for every second. You only pay for when your users actually send requests to your application, right? And you have multiple options. So you can host with Google ADK, you can host with the agent to agent toolkit. You can also even build your own MCP servers and host your MCP servers on Google Cloud. And then when it comes to being able to do inference, you have multiple options, right? So you can run your Gemma 3 models on Cloud Run. You can use a llama to serve your models. You can use VLLM. You can host something or you can get something from Hugging Face and Transformer JS. So you have all of these options to be able to host your models or to be able to run your AI workloads on Google Cloud. And it doesn't stop there. I think you can also even do that with jobs. That is something I've not looked at before. So you can do that with jobs. I think this is something I've not looked at. I've not looked at jobs with LLMs before, but I guess you're able to fine tune a model on Cloud Run jobs. Right. But if the focus is for inference, when you're using Cloud Run services, you use it for inference, not for training, because Cloud Run is not going to stay on, right? You don't want your Cloud Run service to stay on forever because training, you need the machine to stay on and then process that training, right? So that is why probably Cloud Run jobs is suitable for such a use case. So you can explore these docs if you are looking at something around fine-tuning your LLM models. But for something as simple as just hosting your models, you can just go with inference with GPUs, and you can go ahead to host any model that you have and run your inference without worrying about, without worrying about the cost, because you only pay for the requests that are being sent. So if there is no request, maybe at 12 a.m. or something like that, then you are not paying for anything. And I'll just add these notes, which are best practices that you should consider, especially when you are using GPU, whether you want to host the model through the container or through a volume or through the internet, whatever option you want to go with, Google Cloud supports. And so you have all of this variety that you can consider when you are hosting your models. Thank you for joining this session, and let's meet another time where we will look at custom runtimes on Google Cloud Run and distroless images.